All right, and finally, example 7, our application problem. It says use these two data points to obtain a linear function that models average global temperature, f of x, for an atmospheric carbon dioxide concentration of x parts per million. Round m to 3 decimal places and b to 1 decimal place. All right, so don't forget your rounding. It's giving us directions. So first thing I see is we're after a linear function that models the average. So we're looking for the equation. That's what that's telling us, is we're after the equation. So, and it also gives us a clue down here where it says round m to 3 decimal places and b to 1 decimal place. That means I need my slope and my y-intercept. All right, so remember, in order to find slope, you need 2 ordered pairs. Well, they gave me that. They gave me that I'm sorry, not m, but they gave me this ordered pair right here and this one here. So I'm going to let this be my x1, y1, and my x2, y2. So first thing I'm going to do is go find my slope. So to find my slope, remember your equation, y2 minus y1 over x2 minus x1. And I'm going to build my skeleton. I'm going to plug in my y2, 57.64. Plug in my y1, 57.04. Over, I'm going to plug in x2, 354, and x1, 317. So break out your calculator, subtract those. 57.64 minus 57.04 is 0.60. Over 354 minus 317 is 37. And it gives me approximately, rounded to 3 decimal places, 0.016. Then, once you find your slope, you're going to go find, you want to go find the equation of your line. So remember, you can do that because now you know your slope and you can pick one of your ordered pairs. So my slope is going to be 0.016. And let's see, let's use our second ordered pair. So we're going to use the 354 and the 57.64. So this is going to become my x1, y1, and that's my m. So remember, your point slope form is y minus y1 equals m times x minus x1. So I'm going to build a skeleton there. So y minus, skip some space, skip, parenthesis x minus, skip, close. Plug it in. You know your m is 0.016. You know your y1 is 57.64. And your y2, I'm sorry, your x1 is 354. Alright, so we need to distribute. So you got y minus 57.64 equals 0.016x minus 5.664. Then add your 57.64. You do that. This is going to cancel. So you're going to get y equals 0.016x plus 51.976. Now, but remember, it told me we needed to round our y-intercept to 1 decimal place. Well, this 51.976 is my y-intercept. So I'm going to bring that over here. And so we get our function, so I'm going to write it as f of x, because that's what it refers it to in the example, equals the 0.016x plus, when I go to round this to 1 decimal place, that 7 makes it round up. But that's a 9 already, so it's going to force that to round up. So we're going to put 52 and then 0.0. Go ahead and put that 0.0 because that tells us that you rounded to 1 decimal place. So what does this mean? This means that this function models the average global temperature for an atmospheric carbon dioxide concentration of x parts per million. And we can write that out. So the function f of x equals 0.016x plus 52.0 models average global temperature, and I'm just pulling this from our word problem there, for an atmospheric carbon dioxide concentration of X parts per million. Okay, guys, and that's lesson 2.3.